Imagine you are walking around your house with your smartphone. Suddenly, there is a digital chair or playful dog, even though you know they aren't really there. This experience of blending our real surroundings with digital elements is known as augmented reality. Now, AR isn't about creating a completely new world like some video games or movies. Instead, it's about enhancing our current world. It's like wearing a pair of glasses that can project digital objects and information into what you are seeing in real time. Think of the potential. When shopping, you can see how a new couch might look in your house before buying it. Augmented reality bridges the gap between the digital and the tangible, making our interactions more engaging and vivid.
About the types of AR, AR can be divided into two types, marker-based AR and markerless AR. Marker-based AR uses QR codes for digital overlays, while markerless AR includes overlay, counter-based, location-based, and projection-based AR, each offering unique ways to integrate virtual and real worlds. These types highlight AR's adaptability and expanding use cases.
So AR hardware consists of input device, sensors, and display device. These input device and sensors allow users to interact with AR systems. In addition to regular buttons and handles, there can be also some recognition input tools such as gestures and sight. Compared with mobile phone platform, AR has risen to three-dimensional. It provides more diverse sensors. AR software. The first one, motion tracking in AR, is primarily accomplished through the lens of camera that tracks moving parts in the environment. The data is then processed to generate input information. AR applications used to produce real-time results. The depth perception. It is enhanced through the use of scanners like LiDAR, which capture more detailed depth information and enable 3D modeling. Environment understanding. It involves scanning the existing environment to generate the topological information. This includes recognizing key features like counters and symbol points.
AR has many significant applications. In retail, imagine wanting a new sofa but unsure if it will match your living room. With AR, you can use your phone to place that sofa in your room before buying. It's like a virtual try before you buy, making shopping so much easier and fun. Now, think of the IKEA Place app. This app is a perfect example of AR in action. You choose a sofa or any furniture you like, and then through your phone's camera, the app shows you how it looks in your space. So instead of imagining if it fits your room, you can actually see it. It's like magic, but it's just smart shopping with IKEA.
For the Google Translate application, Google Translate's live camera translation takes advantage of the overlay and counter-based features of AR. Google Translate uses overlay technology to put the translated text directly on top of the original text, providing an intuitive experience for users. Counter-based recognizes the shape and the size of the original text, ensuring that the translation is visually consistent with the original text. The combination of the two features makes Google Translate's feature an excellent use for AR technology in everyday applications.
In this part, I will introduce the application of AR in navigation. Let's take the Google Maps application as an example. The developers of Google Map added a new feature called Live View in 2018. When you use this feature, your phone's camera shows you the streets around you in real time, and it also puts an arrow on the screen to point you in the right direction. The smart thing about this feature in terms of development is that it uses the special points it finds in the camera pictures to understand where you are. It also keeps track of these points as you move to figure out where you are going. The app can also even tell you what's around you and put virtual signs on the camera view.
For the classic AR glasses, they were like a bigger screen for AR stuff, but that was about it. They only did simple 2D things and didn't really feel like the real world. But now things have changed, and Apple's Vision Pro is leading the way. Let's look at how Vision Pro can work on its own. It has its own special chip made by Apple called the R1 chip. This means Vision Pro is like its own little computer. It can do both picture and sounds tasks all by itself. Now Vision Pro is really good at understanding in the real world. It uses its own cameras to see what's around you and shows it on the screen. Then it adds digital stuff on the top of that. It's not just AR, it's like a mix of AR and VR. Some people call it the mixed reality. Last, Vision Pro has some cool new features. In its first version, you can do things like 3D meetings with virtual people and see digital things in the real world. These features make AR even more fun and real.
AR advantages. So, unlike the mobile screen that limit data to a two-dimensional space, AR integration information into users' real-time environment, providing a more natural and intuitive interface. AR can also overlay real-time information or visuals directly onto users' field of view. This feature is invaluable in various applications such as navigation, medical diagnosis, and maintenance tasks. So AR systems also allow users to interact with applications through the gestures or spatial movements, making the experience more intuitive and flexible. It also gives us a glimpse of next-generation computing platform.
As we look at AR's future, we see it's a technology frontier with significant changes ahead. Firstly, battery life in AR devices drains quickly due to high computational needs. Even Apple's Vision Pro relies on external power, sacrificing mobility. Secondly, outdoor use is another hurdle. Current devices, even with 12 millisecond latency, aren't safe enough for scenario like autonomous driving. Lastly, lack of standardization hampers progress. Rapid tech change lead to fragmented user experience and lack of universal standards. To grow, AR needs longer battery life, safe outdoor use, and industry-wide standard.
In summary, AR is transforming industries such as retail and translation, providing immersive experiences. IKEA uses AR for virtual furniture placement, while Google's products enhance navigation and cross-cultural communication. The evolution of AR glasses to smart platforms shows that the adoption of AR across industries is accelerating.
Right. AR technology has improved quickly, making things like entertainment, education, and work easier. In the coming years, AR will become even more important, especially in areas like using it for important medical procedures. We might also see AR and VR coming together, giving us a cool mix of real and digital experiences. In conclusion, AR's future looks super exciting with lots of cool things waiting to happen.